Hello, welcome to stream number 38 in this series where we're programming an NES game live on Twitch. Last time, in the previous stream, we were trying to figure out how we were going to handle changing the name table attributes so that as we scrolled, the tiles had the appropriate colors, because if you recall, they do not currently. So we ran into some interesting challenges with the fact that the screen size is slightly different than the ideal screen size that we would want, given that our meta tiles are 4 tiles by 4 tiles. And what we discussed was that because we are currently doing tiles that are like this, the last 2 rows here of 8 by 8 tiles on the entire screen are essentially empty, which is fine because we have our status bar covering them. And then we eventually populate those with the tiles that we are scrolling with. But the problem now becomes that this whole point of having these nice 32 by 32 meta tiles that will align easily with the attributes in the name table gets thrown off by this, because for the first pass and essentially for every other pass across the name table, we are updating attributes across 2 different attribute rows. So it's not quite as simple as I had hoped. If we were doing scrolling horizontally, then that would be great and that wouldn't be a problem, but we are scrolling vertically, so it is. And just like I discussed last time, it has nothing to do with the size of anything related to the way the emulator is displaying. It has to do with the way that the screen size is broken down into the 256 by 240. Just some housekeeping things from some stuff I was doing before the stream. Nothing too complex, but I figured I'll cover it here. It wasn't so interesting that it was worth doing, at least in my mind, on stream, but I was informed of this cool macro called repeat, or I guess it's a preprocessor. I don't know. It's a command in CC65, lets you write some code and say, all right, I want to have this repeated exactly as is, any arbitrary number of times. This is really useful for things where you're unrolling an exact loop. And in the case of something like the controller code here, you can see I've changed the repeat to repeat 8, and then it does our rotate right, rotate left in order to stack the bits into the controller variable, which is really nice, because then it takes this and essentially duplicates this set of instructions 8 times instead of me having to write it out that way. So I thought that was useful. I've changed some of the code in a few places to use that. So like here where we're writing the meta tiles out 4 at a time, doing that. Here's another place. So just to show you what I mean, you do repeat 4 and rep. Hey Vashtarek, how are you? And so that changes the code to do the ASL 4 times. Now, keep in mind, this doesn't reduce the number of instructions in any way. It is literally just reducing the amount of code we have to write, and so you can see the code we have here is exactly the same as before. The game runs the same way as it did previously. It's just a nice shorthand way of handling some of that stuff. So that was I thought that was a cool cool little shorthand, and I want to say that it was CPP Chris who brought that up in the chat on Discord on Nintendo Age, so thanks to him for that. So today, what I'm hoping to accomplish on the stream here is I'd like to make it so that we can get the attributes loading. And if we can do that tonight, I'll be happy with calling it a night. As I mentioned on Twitter, I'm kind of flying solo tonight a little bit, so I'm hoping to keep this relatively short. Of course, I say that about a lot of streams, and then I go on and on and on. I like to talk. Alright, so just to refresh my memory, because I never remember, when we're talking about the way that the attributes work in the name table, if this is the 4 quadrants, and each quadrant is 2 by 2, then this is shifted by 0. This is shifted by, oh, no, see, and this is why I have to look, because I always forget. So this is shifted by 0, this is shifted by 2, this is shifted by 4, and this is shifted by 6. So if we look at the byte when we're writing it out, if we have our, let's just say this is 1 byte. I'm not going to write all the bits. This is 0, this is 2, this is 4, and this is 6, right? So there are 2 hex bytes. Actually, no, there are not 2 hex bytes. There are 2. This is 4 bits. This is 4 bits. So this is 2 bits, and that's, yeah. All right. Anyway, so this corresponds to, if this were hex, this is, you know, the 0, 0. And if we wanted to change the attributes so that every attribute was set to use palette 1, we'd end up with 1 0 1 0 1 0 1 0 in binary, which is A, right? Because 1 0 1 0 is 10, and 1 0 1 0 is 10. All right, so just trying to look at the way that this is arranged and see if there's a simple way for us to handle this, because basically what we're going to need to do is half the time we're going to need to update alternating. Well, let me think about that. Maybe there isn't any difference. Maybe I'm thinking it's different, but really it's not. In the case where the meta tile doesn't overlap perfectly, let me draw this in a different color. In the case where the meta tile doesn't overlap perfectly, oh, actually, that's not even right. It's this. Right? Even that's too much. My drawing. I'm trying to make this proportional so that it looks reasonably good and makes sense. So, and then this would be a 0 and a 2 of some other set of attributes that then have 4 and 6 over here. And so when we update this, I have to update in memory. These are 2 rows. I'm updating. If we have the array in memory stacked like this, we're at 6420, 6420. I'm updating these 2, and then I'm updating these 2 half the time. And then let's see, and then when we go to do the update again, yeah, you know, it's actually not that bad, because, and then the reason I say it's not that bad is because it's consistent, right? So there's no weird pattern here necessarily. So if I draw this out a little bit further so I can kind of visualize what I'm thinking. So if we update this at the bottommost row, the next time we need to update it, we have to do the same thing. We have to update this and this. And then the next time we have to update this and this, until we get to the point where we have updated the entire set of attributes for the name table, and we're starting over at the bottom, and then we're doing this, and then we're doing this, and then we're going back to that alternating pattern again. So it's not super crazy. It's still not as simple as I had hoped. And we obviously only need to do the update of the attribute. Let's see. So each of these is actually a 4x4, right? So when we hit the bottommost row, so when we skip to the next meta tile, that's when we have to do that update. So we only have to do the update once every 4 rows. So that's not too bad either. And we can determine that because we're tracking that anyway. We're tracking that anyway for our counter for the meta tiles. So what we do is we say, okay, let's see. Oh, one other thing I want to mention, apparently, and I didn't realize this until we were talking on the Discord, you can do the arithmetic shift left on addresses. So if I wanted to do an ASL on a particular value in memory, but I didn't need it at that time, I can do it directly. I can say LDA M tile Y, ASL M tile Y instead of loading it into A and shifting it. But if you're doing it enough times, it's actually more efficient to load it into the accumulator. Let's say I need to do the ASL a few times. You can see that the number of cycles to do the ASL 6, it's 3 times longer than doing it on the accumulator. So it can be simpler to write it that way with the, and I'm assuming the worst case scenario that you're out of 0 page, but that's not necessarily true. But the point is that it could be substantially more cycles than doing it in the accumulator. But good to know in case we decide we need to do it. I mean, that's one of the challenges of working on this, is that without being, it's not like when you're working in C or C# for a while. I mean, I've been programming in C for a really long time, so I kind of remember all of the things that I can do there. In C#, I'm not as good, but I still generally remember what I can do pretty efficiently without having to go look it up. But with this, because it's so new, yeah, it tends to be a little bit more challenging. And speaking of optimization, one other thing that I did was, there's this cool article that if you haven't played the homebrew game Lizard, you definitely should. It's really hard, but it's a really cool game. And Brad Smith, who made it, right? That's his name, right? Let me bring that up real quick. Brad Smith, Lizard. Yeah. So he wrote a really great article on how he did some work optimizing the code. And one thing that was really cool that he brought up, I'm sorry, this is a slight tangent, but I promise it'll be quick. One thing that he brought up, which I've seen other people discuss, is that you can, so there are these bits you can set in register 2001 for the color emphasis. And what he mentioned was that for debugging purposes, for performance, he enabled code to write those color emphasis bits while his code was running. And the idea was that he wanted to see how much of a frame his code was taking up. So what you can do is you can say, all right, if you define, I have this, if I define perf debug and I build it, now when it runs, you can actually see when the game is running, there's this blue and green part of the screen that shows up. If I slow it down a little bit, you can see it better. And what that is that is the emphasis bit being set. And so as I add more stuff to the game loop, for example, you can see that green part expanding, and that's the game loop evaluating the entities in the game loop, and that's showing how much of the frame time that's taking up. So that's a neat visual way to actually see how much time your code is taking, because the Lua stuff that I've done is pretty good in terms of showing number of cycles, and this offset stuff got messed up, but you can see like the game loop is taking approximately 4,300 cycles. But this kind of puts a nice visual representation of what that looks like in comparison to rendering the whole screen, because it seems like, for example, the 11,000 is a huge amount of cycles, but I mean, it's less. Well, we're getting on about half the frame time, so kind of cool, interesting way of doing it. Just wanted to show it there, and then I can always turn it off by removing that definition of perf debug, and then bring it back up and it goes away. So just a cool little debug tool. All right, so back to what I was saying. So when we're loading in our tiles, we have this code that we're doing, but there's a counter where we are incrementing rows up until the point where we hit 0, or sorry, I guess we're decrementing. So we're decrementing it but basically 4 times. So we're saying, okay, just to revisit it, what we're saying is, rather than trying to keep track in absolute terms of how the screen is loaded and tracking, we're saying, well, the screen is really composed of these rows of meta tiles, and we can also count frames and know that that corresponds to 1 pixel in each row. And so we say, okay, for every 8 loops, we want to load a new row, and then after doing that 4 times, we know we've hit the end of 1 meta tile, so now we need to go to the next meta tile. So it's like a really simple counter mechanism to track how to load the rows and the meta tiles, the rows of the meta tiles. So what we need to do here, I think, this is the right place for us to modify the attribute, or make some sort of something to let us know that it's time to modify the attributes, because this is when we're switching to the next row of meta tiles, which means that the next row that we're going to write into the name table will have a new palette potentially. So let's see what we're using here in this. So what I think I want to do, branch not equal, comparative pause, process scrolling. So let me see, are we using, doesn't look like it. So what I think I want to do, okay, we are using temp here for something. What are we using it for? Grab the internal row for the meta tile, multiply that by 4, and add that to our offset to get the row we need. So that stores into temp. Oh, because then we are using temp right, so we're using temp to add that later. This gets added later in the section after we load the meta tile value. As I'm going, I'm trying to add more commenting because, as you may recall from the stream where I went and revisited our level loading code, without it, I tend to forget, since there's quite a bit of time between streams, and I mean, just with anything, if you're not working on it regularly, you may you tend to forget. So let's see. I think we have one called temp2 that we can use. Basically what I want to do is I want to use something as a flag to indicate that we need to update the attributes. So let's see. So process it, scrolling. So let's do this. I think temp2 is not a thing. No. Let's see what we've got here. I think what I want to do is I want to reuse attribute mode Yeah. So, okay. So what I'm going to do is I'm going to load right now the attribute mode only uses basically the first bit to indicate which bit is being used. So I want to load A with what would that be? 1, 2, 4, 8 2, 4, 6, 8, 14. So F and E. I want to do that because I want to say and attribute mode. Does that work that way? Yeah. So I'm going to load that, so we clear that out, and then we're going to store it back into attribute mode. Right? I think I've got that right. So if this works correctly, then A should be 1. And then if I do... Wait a minute. That's not what I wanted to do. I wanted to do this. If the value is 1, store A into 0. Load A1 and with the address Y. Yeah. Yep. Okay, so and then if this works the way that I'm thinking, then when I do this and run it, I should get 1. Load A, store A, load A, and with the value of 0. Oh, okay, so this is the bit mask and this is the value. Okay. So this isn't what I wanted, because basically what I want to do is I want to say, okay, this, and then if I load A with this and it, now I'm going to get just 1 instead of 0. So instead of 1, 1. So it's doing the and. Well, actually, that shouldn't matter. It shouldn't matter. It's all the same. Am I just being a dummy? What? I don't understand. Load A, store it. You get 1, 1. Then load A with 0, 1, and it with the value in 0. And it should be 1, 1, and 0, 1. Oh, okay. It doesn't change the value of... Got it. I was being a dummy, but for a different reason. So, okay. Yeah, so... Except that it's the opposite, so we do that. So the mode now, if it was... Excuse me. If it was set to 1, because we were using one of the split modes, then it's going to stay 1, but we won't impact this flag that we want to use. So we have that. We store that in mtile y. We're going to load A with we'll just say bit 2 is what we want. So we're going to OR that. We're going to OR that with adder mode. Restore that. So basically what this is going to do is set bit 2 to 1 so that we know we need to update the attributes or the adder mode value so that bit 2 is, keep doing that, bit 2 is set. Store this back. We need to, moving forward, I mean, we don't need to, but I'd like to start doing a little bit more with packing bits than what I have been. Not that we're necessarily running out of memory or anything, but better to be a little proactive with that if we can. All right, so the next thing we need to do, let's see. Maybe this is where we prepare the attribute stuff as well, because we have adder mode getting set here to be in split mode. We're setting up the first place we need to do our update to the attributes. Which is 38. So that's row 38 in hex. What is that? Or it's not row 38, it's offset 38. So that's 56. Right, so that's the 60. If you recall, there are 64 attributes, and we want to go off. We want to start one row before that. We actually, or that's the last row of attributes, because we want to start there, and like we were talking about, we need to do the updates starting. If I can I undo these for a second? Going alternating here. So we're going to do, if this is the last row, we're going to update this these bits across the whole screen, and these bits across the whole screen, and we'll do that consistently. And then when we get to the top of the screen, the top of the name table will start back over here, but we'll then be updating across the whole thing. So yeah, I guess that's as good a place as any to do the update. Maybe we don't need to modify it, the mode. Well, we'll see. All right, so we don't need to modify the row because that's already set up to where we want it to be. Thinking about it, because we're already going to be pointing to the appropriate location. So that's that. Do we need to do the adder counter? Maybe we don't. I don't think we will. All right, so we've got our increment there, and now what we need to do is we need to determine we need to update the appropriate attribute. So we can do this one set of attributes at a time, depending on if it's split or not. So first we need to load A with attribute, and then we want to do an AND of 2 and branch if equal to skip attribute load. And the reason we want to do that is because, or actually we'll reuse this label. And the reason we want to do that is because we are saying, okay, if if the let me think about this for a second. If the bit hasn't been set, then the well, wait a minute. I'm confused now. Oh, I'm unconfused, sorry. If the bit hasn't been set, then we don't need to set the attribute. We, no matter what, have to potentially skip. And that's because we will traverse the same meta tile row 4 times as we process each individual row in the meta tile before we get to the next one that we then potentially have to update the attributes for. Probably want to cache that stuff at some point, because right now we're recalculating every time the lookup into the row mem, where we could, unless we're getting to the next unless we're going into the next meta tile row, all we need to know is the base value of y, and then just keep incrementing for the 8 rows that we need to do it for. Anyway, not today's problem, since this part of the code is actually pretty minimal. Alright, so branch of equal. So basically, check the bit for attribute mode to see if we traversed into a new meta tile row. If it's 0, if this is 0, then bit 2 wasn't set, and we can skip modifying the attributes. Okay. Otherwise, we then want to load the attribute mode again and AND it with 1, because we want to know, okay, are we doing split or no split? So compare it to split. If it's not equal, then we're going to go to set attribute no split. I don't know if any of this is actually worth keeping. So if we are splitting, then what we are going to do is we're going to do we're going to update 2 rows. So what we're going to do is we're going to load how are we going to do this? So we're going to load A with row mem y. That's our attribute value that we need to store. Then transfer y to A and push. I'm not sure I like that. Store y into temp. I don't think we need temp anymore at this point. Let's see. Now we do, because we're using it here. So temp has to be preserved. All right, so is it time to introduce temp2? Store y into temp2, save off y, offset for when we're done modifying the attribute. The reason we need to do this is because we need to use y to, do we need to use y to do this? Actually, we may only need to do this for x. X has, let's see, x is going to be reset to 0, isn't it? Transfer a to x. Oh, it's not reset to 0, but the value is reset every time. So let's see. We need to look up. So we have the attribute value. And now, because we're split, and this is the first part of the split, we want to take that value and put it in the lower significant bits of the byte at the row that we're starting with. So let's see. And then we need to do that same value for the row before that. So let's see. The first thing we want to do is shift left twice, and then so let's see if I've got that right. We're going to load the attribute memory, the attribute value. We're going to shift it left twice. Then we're going to OR the same value onto the lower 2 bits, because it's going to be the value of either 0 through 3. So let's say it was 3. If the value is 3, then A will start off with 1, 1. We'll shift it over twice, and we'll get 1, 1, 0, 0. And then we're going to do an OR with the same attribute value, so this will become 1, 1 again. And that gives us our lower 4 bits. And so then what we need to do is we need to say, okay, we want to OR that with... We want to OR that with the value. Let's see if we can do this with X offset. We can. So what we want to do is we want to offset that with adder, what did we call it? Adder mem, and then X. And then what we will do, well, actually, well, let's store X into temp2, because we need to save this off for the loop, loading the metatile rows. Oh, well, you don't even need to save that. because it gets replaced. Okay, cool. So we don't care about that. We do need to load load X with adder index, because that is going to give us our first value that we need to clobber effectively. So we've loaded the bits, we're shifting them, we're reloading into the lower 2 bits. Now we are loading X with the index, and now what I want to do, I guess what I want to do is I want to store this, because I want to load, I just want to load the value into here, and then I want to AND it. And I want to modify the lower 4 bits to be 0. Well, that's not going to do it. Wait, yes. Come on, brain. Help me out here. This is, yeah, that's going to modify why am I right? Yeah, okay. Sometimes brain. So yeah, so the lower 4 bits will be zeroed out, and then we're just gonna OR A with temp2, and that's gonna give us our new attribute value, and then we're gonna store that back into adder_mem X, and then oh, this was the part. Okay, so this, I remember now. This was the part where I said, well, this is going to be potentially a problem. Because right now, what we're doing is we are loading, we're loading the name table using the 2007 register, which is fine. But it's not fine because we need to also modify memory in the PPU using 2007 by loading the appropriate address into 2006 and then using 2007 to update the attribute table. We don't want to have to keep swapping between addresses. It's really inefficient to have to do that. And the reason it's inefficient isn't even, I don't think that there's a penalty necessarily from the PPU, but there's certainly a penalty of the amount of code that you have to write to keep swapping back and forth between addresses like that. I could even be wrong about that, but it just, you know, it feels like the wrong thing to be doing. So we have the ability to update the attribute memory, which is a RAM-based copy of the attribute memory. I'm wondering if then what we can do is at the end go and update the attribute rows properly once the tiles have been loaded. So I don't know how exactly we'll do that, but let's see if we can get the memory part done properly first. So that's that, and then what we need to do is, let's see. So X has the attribute index in it. So transfer X to A. So now that we can, now what we need to do is an operation on X. We want to set the carry. We want to subtract 8. And the reason we want to do that is because we've set the attribute at the location that we needed to for attribute index. And then what we need to do is we need to do the attribute one row previous. We only don't want to do that if the attribute index is already 0. But that won't be the case for, let's see, for the case where we're splitting. For the case where we're splitting, that'll be the only time that that matters, because we will be updating. If we are at the top of the screen, we would be updating to 0, and then we would need to roll back. So this gets more and more complicated, doesn't it? Let's just do this for now. So transfer x to a, subtract 8 from that. So what we're doing here is we've updated the 1 attribute at that position. Now update the previous row. So now that we've done that, the code is slightly different. So what we would do is we'd say, let's see. So we have so now what we need to do is we need to load row mem y, and then we want to do this shift 4 times, and that will, now we actually want to do it 6 times first, and then we want to no, actually, we'll do it. No, yeah, that works. Maybe temp2. Do we modify temp2? That actually, we can reuse that. So I was going to say we need to shift it 6 times, but that's not actually true, because what we need to do is load the bits the same way and then shift that whole thing over by 4 bits. But luckily, we can do that by just taking temp2 and then repeat 4, shift left, and rep store temp2. And then it's the same thing. So what we're going to do is we're going to load adder_mem x. We need to transfer. This should be transfer x to a. This should be transfer a to x. So that now we have the new location. So that's good. And then we say, okay, load a adder_mem x. And then we want to do an AND on that, and we want to do the reverse. We want to zero out the most significant bits, or the 4 bits anyway. And then we want to do an OR on that to set that, and then we want to store that in adder_mem x. And that's it for that. The only thing we need to do now is increment adder index to the next position. So let me think about that. If we do that, we've updated the attributes all the way, and then the next position. Okay, so then let's do that. Let's increment adder index, and what we need to do is, when we're done with all of this, we need to, well, let's jump to done with attributes, which we're not, obviously, but we'll get there in a second. So when we're done with the attributes, what we need to do is presumably we've updated the row with the appropriate attributes. And now what we've done is we've moved the attribute index up a full row, right? So it's drawing in white, which doesn't help. If this is our attribute memory, right? We were here, we've updated everything along this, and now we're here. And what we want to do is actually go back two rows. So load A, adder index, set carry, subtract 16, store adder index. The question is, do we need to do that? Well, that needs to be done actually at the end. Process screen memory, otherwise jump, skip, row, load. Screen memory, load A, compare 1F. This is restarting us back at the yeah. So set up the proper scroll. So we're done. So here is where we would want to load a adder mode. And to branch if not branch if equal, so if it's 0, skip modify adder index. So check if we modified, if we moved into a new meta tile row. If we did, then move adder index back to the next row, minus 16. Minus equals 16. So I think that's right in terms of, modifying that. Now the only problem is that we're done loading the row into memory, but we haven't actually modified the attributes. So what we need to do here is we have to say, okay, so we've done this. Now we have to load the attributes in from the adder mem that we've modified. So what we would do is we'd say load x, actually transfer A to x because that's our index, and then we would say load A to 3, and I think C0 is what I said. So store A in 2006. All right, so transfer A to X. Set X to index so we can write the adder memory, load up address 23C0 plus adder index. So we store that, and then we want to do, I think we need to actually redo this. We need to bit 2002 just to ensure that this is right. Let's see. Yeah. So we want to do that bit on 2002 to make sure our load of the 2006 register happens correctly. So this is C0, and then we want to clear carry and add adder index, and then will that cause, let's see, C0 plus, what's 64 in hex? Just 440. So C0 plus. Okay, so worst case scenario. Okay, yeah, no, that's good. We don't have to worry about the carry on the add. So add that, then store that in 2006, and then all we need to know is essentially if we're doing 2 rows or 1. If we were in, oh, actually, and that's interesting because if we're in split mode, we need to load the row that we went back to, which is the next row, plus the following row. So we have to do 16 updates. If we're not in split mode, we just do the row that we had just modified. All right, so we store that. Which means that, let's see. So load load compare. So let's see. So branch not equal to load split address. Oh no. Branch if not equal to load address, load adder address. Otherwise, this is load split adder address, and yeah, so that's that. And then what we want to do, we store that, and then we want to load y with 16 because that's going to be our countdown. Jump load adder values. This is going to be load split. This is just load adder address, load a adder index. This actually can be, I think, the same. Adder index for transfer to PPU. So the reason I moved that was because I wanted to make sure that we've got consistent behavior here, because that part doesn't really need to change. It's just the part where we set up the address that's going to be modified in the value of y, and I guess the value of x too. So in this case, we're going to load X at our index. Well, we're going to load A at our index, and then we're going to clear carry and add carry to, we're going to add 8 to that, and then transfer A to X. And the reason is because if we're not splitting, we need to do just the updated row, not the row and its previous row. So we've got that. So X is now set up to get the values from memory. We've got load A, 2, 3, store that into 2006. We still have to do the bit 2002. Load A, C0. Clear the carry, add load A. Let's do this. Let's transfer X to A, clear carry, add carry, C0. That works just as well in this case because adder index is not the value we necessarily want to use right here. In fact, we can do that same trick here. We say transfer X to A, clear carry, load, and add C0. Just kind of saves us a step. Right, so that's add carry C0, and then store that in 2006. And then load Y, we only need to do 8. And then this is load adder values. So now we're at a point where we've got our attribute addresses set up, and we just need to do a bunch of 2007 writes, and we're going to do that by, we're going to be decrementing Y, compare Y to 0, branch not equal to load adder values. So that's just, I'm setting up the loop here, making sure I don't get into an infinite loop accidentally. So let's see, so we want to load A, adder mem X, which has the value we want to write. We want to store A in 2007, and then we want to increment X. We're going to simultaneously decrement Y, compare it to 0, load attribute values. I think that is okay. The only thing that we didn't do that I was thinking about while we were working on this was if the attribute index is 0 and we subtract 8, we don't want to obviously minus 8 from that. What we're going to end up with is if we have 0 and we do minus 8, we're going to end up with F8, which is 248, right? So what we need to do is we need to check that. So we subtract with carry, branch carry, clear, right? If it's clear, then load A, 0, set carry, subtract C8, assemble, run, carry is clear, make this 8, it should still be set. Okay, so if the carry is clear, then it's borrowed from the carry flag, which means that we overlapped. We wrapped around. So branch carry set to skip skip attribute wrap. which is here, skip attribute wrap. And basically all we have to do here is we have to say, okay, we've wrapped, which means that our attribute index needs to go back to the top, which means that we're back at 56 hex, 56 decimal, which is 38 hex. If carry is set, then we didn't wrap, but if it's clear, then we've wrapped and need to reset the adder index. And then we didn't actually implement the no split condition, but let's see how this goes. This is going to be interesting to say the very least. All right, so let's do this. We're here, store A into 7F A. I think that's the address I was using for debugging purposes. So this is our little debugging set here. Let's go into the debugger, make sure that this is configured, reload the ROM. Okay, so we've hit the point where we are now, if we look at the name table, we've loaded four tiles from the meta tile. So now we're going to be trying to update the attribute memory. God help me. Okay. So that looks like, let's see, where is that in memory here? That is, oh crap. Adder mem. It should be adder buffer. Use the wrong variable. All right. So that's set attribute news, blah blah. That's fine. Where is the actual update? Should be attribute buffer. Okay. So let's reload this because that's definitely not going to work. Run. Okay, so we let's go back to the PPU name table viewer. Again, we've got 4 rows that were just updated, and so now let's look at what we're doing here. Where is that? There. Okay, so we're going to load the attribute mode. Interesting. So why didn't that bit get set? mtile y. It should, right? mtile y is the first value, and that's 3. So adder mode, did it just do something stupid with the bits? load A to or A attribute mode, store A attribute mode. Let's do this. Reload that. Okay, so we've gotten to this point, so we're going to step over. We're loading A with, wait a minute, Y. Did not call that in X and Y. Increment meta tile row. Increment meta tile sub row. Oh, is it in a sub row? No, it shouldn't be. It should be loading a brand new row. Let's move this back further. Run, start. Okay, so loading A with 0. Oh, damn it, I hit that wrong button. Really wish it had shortcut keys, like, you know, in Visual Studio you can use F5 and F10 and all that other good stuff. It makes it a little bit easier than having to hit these buttons. All right, so store, okay. So load A 0, store A into address 3, so we're making that 0. Decrement. Oh, I see. Because we were not traversing. Because we weren't traversing the meta tile. Well, okay. Okay. That makes sense, but that can be fixed. So basically what was happening is that because I was initializing M tile Y to 4 instead of 0, like it would be at runtime, what you end up with is you end up with slightly inconsistent behavior compared to the real code. In the real code, when you get done with a meta tile, you end up with M tile Y being 0, and so it will traverse the code that then has to set up things like I wanted. But because in this setup code for loading the level, I was setting it to 4, the behavior was essentially the same, but it wasn't calling all the code that handled the loop over. So it was slightly different, which when we don't care about that is fine, but because we are now basing things off of that rollover, that matters. So let's see. So step over, load A 0, store A, yeah, decrement that, it gets FF, we load it into A, we compare it to FF. Now we're loading 3, we're storing A 3, we're loading, so we're here now. Now we're loading 2, and we're going to set the attribute mode properly. That's why it's 3 now. That's good. And so we should still have that breakpoint trigger. Where is that? Here now. So let's see. So now when we go to here, yeah, so we're going to load attribute mode, which is now set to 3 like it's supposed to be. And if we look at the name table, we should still see the 4 tiles got low. Well, it may not because of the way that the emulator is drawing this. Let's do this. Let's get rid of this breakpoint now because we know that that's working properly. And let's reload the game and make sure that we are seeing the 4 tiles get updated as expected in the name table now. Still. Okay, so they're not. That's something. Load a 3. Yeah, so that, I'm curious, what would happen? Where is this? So we're getting random bits of nonsense into the level. It's almost exactly right in terms of the tiles, but something is messing this up. So let's do this. I would like to know why changing that from 4 to 0 broke the code. Load 16 clear. I bet it's because tile Y is also not set properly. What would tile Y be under these circumstances? I think this is just, again, more initialization. Well, this looks okay. Let me do this. Let me get rid of the code that's actually handling all of this nonsense for the attributes here for a second. Come on. Oh, you bastard. Okay. I just want to see if that change actually broke the tile loading or if it's just the meta tile stuff broke the tile loading. Either way is fine. I just want to know which one it is. Or it's not fine, but it's, as long as I know which is the situation, we can handle it. Yeah, it looks like we're, oh, you know what? No. It's still processing the attributes here, which we need to also take care of, because that's gonna skip row load, load A attribute mode. We can comment all that out too. Again, for just a moment to make sure that we have a sanity check here with that change that I made. Okay, so by all accounts, that change that I made in and of itself didn't actually modify the way that the meta tile loading was working, so that's good. That means that that was less problematic than potentially I thought at first. So now I don't know why the emulator was not showing those tiles, but it seems like they're getting loaded in. Oops, what was that all about? go to the debugger, turn this back on, start. All right, so we've hit that point. Name table, still not reflecting the change for some reason. Not 100% sure why that is, but okay, whatever. So let's step over this code, make sure it makes sense. So we're stepping over. We did hit the flag for loading the attributes, right? So what we said was, okay, if it was equal, meaning it's 0, then if we didn't set that bit, then we're done. We don't need to load any new attributes. But because this is the first row we're loading in for that meta tile, we do have to set those attributes properly. So let's step over that, and that brings us into loading the attribute mode again. And now we're going to just do an AND with 1 to determine if it's split mode or not. So we compare it with 1, and if it's not equal, we're going to go to the non-split mode, but it is split. So we're going to load in our first attribute value into memory, or the first palette, which if we look at the PPU, palette 0 is for the gradient. If we look at our map for a second here, the next thing we would be loading from the map is a gradient tile, so that makes sense. So we're going to do these shifts, which don't do anything because it's value 0. Then we're going to OR 0 again. Now we're going to load X with the value attribute index, which will have 38, which is the last row. That makes sense. And then we're going to store. So X has that value. So then we're going to store A, which is our attribute value that we are going to need to modify the attribute memory with into temp2. Now we have X loaded with our index. We're going to load the current value of attribute buffer with that index. That's going to give us the value 0. We're going to do an AND on that to remove the lower 4 bits, and then we're going to OR our attribute value onto that. We're going to store that back in. Then we're going to transfer X to A, and oh, are we doing this prematurely? No, no, that's right. So now we're gonna store, yeah, we're gonna subtract to go to the previous row. And then we're not at 0, so we don't have to wrap it around. Now we're going to transfer A back to X, which makes it 30, which makes sense because we subtracted 8. We're going to load A now with the value of the attributes that we had pre-computed, and we're going to shift it by 4, which doesn't do anything because the value is 0. And then we're going to store that back into temp2, because that's where we need it. And then we're going to load again the value in attribute buffer. We're going to AND it so we get rid of the top 4 bits, and then we're going to OR the value of the attribute stuff. We're going to store that back into our attribute buffer at that position of 30, and then we're going to increment attribute index by 1. It goes to 39, and then we're done with the attributes. So we can increment Y, compare Y to 16, which it should not be equal to. We did not modify Y anywhere here, So we're good for the next meta tile. So same thing again. So we just basically need to run till we hit the breakpoint again. And let's see, so now y will load the next value. Again, we're going to check. We're going to check if we're in. I guess we could technically make two versions of this code where we don't have to keep checking to see if we're in split mode or not. Might be a little bit faster, but not important to do right now. So, and see if we're in split mode and if we've loaded a new thing. So it says we have, so now we're loading attribute mode again and we're checking the mode. So branch if not equal. Okay, so now we're loading the next value. It's 0, so that's going to look a lot like the same thing. Trying to see if we can get a value that's not 0. What would the value? Where would that be? We don't actually have anything there. Maybe we should change. I'm going to change the map slightly. I'm going to change the map here to make this first one a blue tile, just for the sake of our work here, because otherwise it's going to be really boring going through a whole bunch of rows where nothing happens. So let's re-export that from tiled, and then go back to the asset tool and re-export that. We've exported the map. So let's go back to this, and where's level 1 bin? There it is. Let's go back to here and replace level 1 bin with the new one. And let's reassemble our code and reload the ROM. And let's go back to the debugger and run and start. Okay. So this should hopefully be a little bit more interesting, because we should start seeing values that get loaded from. Why is why is that still 0? The first tile should be, let's see. Did it not update? Oh, it didn't update it. It's weird. What happened? Export project. It's there. I'm glad I caught that now, because that would not have been fun to spend all this time trying to debug why the information is wrong when it's because it didn't load the game properly. All right, or load into the game properly, I should say. What happened? Did this screw up the export or something? What's the deal, tiled? Export. Export as. Yeah. Save. Replace. Okay. I mean, it shows it right in the asset tool. I don't care about this right now. I just want this to export. Okay, export. Level 1. Replace. EUX just not reloading the ROM properly? What's going on? Oh, it's skipping that. It's skipping that row. Was that because of the change that I made for mtile_y? Is that what happened? It shouldn't have, or has it been doing that all along? That was not the right place to make that modification. Oops. This should be 4. Let's see. Okay, so that had the unintended consequence of, oh, okay. Yeah, I see. Because we wanted it to load the row that it was on, not skip it. And okay. Well, it's too bad I didn't catch that a little earlier. That's fine. Ain't nothing we can't fix. So basically what we need to do then is we need to compare mtile_y. Wait, no. Store A. Load A. mtile_y. Compare it with 4. Branch not equal to skip. We'll call the skip. Initial flag. Now that's a stupid name. What is it doing? It's skip attribute mode flag. Here, so check if this is 4, which is the first time around, but we want to consider this a meta-tile load. So branch one equals. So then what we need to do is load A with the value 2, and then OR A with adder mode and store A adder mode. Right, which is what we were doing here. So again, the only reason we need to do this is because the first time through, we don't want it to skip the current row it's set to, and I didn't want to have it set to one row too far down in the index to just trigger the next meta-tile row. I mean, I guess I could have done that too. Either way, you know, maybe that's a better way. That might be a better way, because this requires checking every time, and that way doesn't. That way you just, yeah, that's actually a better way. All right, so mtile_y, where is that? So make that 0. And then I want to, so this is the number of meta tiles in a single screen plus the attribute plus bytes initially included. And then let me think about that. But we need to force it to be offset by 16 so that it skips immediately to the next one. Is that right? So 7C minus 106C. That might be wrong. Oh, that's okay. All right, so that actually loaded that row. So let's go to the debugger and look and make sure, because it actually looked like it updated the attributes properly, but I want to walk through this and make sure that we're looking good. All right, name table viewer. Oh, it did load it. Okay. All right. So let's go and look at, so this load A, that's our, that is our first set of attributes. Let me think about that. Okay, so that's okay. So, well, actually, is that okay? Why? I guess I'm loading it up all the way. Yeah, I guess that's okay. They can only have one attribute anyway, so, or one set of palettes anyway. So, all right, so I'm shifting, so we're gonna get why, whoa, arithmetic shift left, so it shifted it, but did it shift the carry on? Because that wouldn't be what I wanted. Shift all bits to the left, 0 is shifted into bit 0, and the original bit is A0. No, I guess that's because I just shifted it 4 times. 7FA. It should be 4 bits, not 2 bits. Okay, so we got our value of AA. We're going to shift it 4 times, so now we have A0. Now we're going to OR A that with the value in the attribute table, which gives us AA. But that's not right either, because wait a minute, what the hell am I doing here? Why did I do it this way? Maybe because I didn't remember how I stored the value for it in the tool. I don't actually need to do this. If I'm doing it in the most significant... Oh, okay. Yes. All right. So in the tool... All right. okay. So what I'm trying to do here, I'm trying to load up the value, assuming that I only wrote it once to the as a single value in the byte, but I actually pre-shifted it. I guess I should have looked at that. if you look in, I remember that now. So when I go to write the palette values, where is it? Shift 6. You can see I'm shifting it into every set of 4 bits. So I don't actually need to do this. What I do need to do though is I do need to, let's see, so I'm trying to set the lower 4 bits. So I just basically need to load the value and then and the value with the OF to zero out the bits I don't care about, so that when I do the OR, it doesn't have any negative impact. Let me store that. And then, let's see. And then we shift it by 4. That'll work. Okay. Well, I mean, that's good. That makes the code a little bit more efficient because I don't have to do as many shift operations. It's just a little silly that I forgot, but this is the way it goes when you're kind of working on something on and off, and even then, you know, you make stupid mistakes because you don't remember things. But all right, so let's see, we've got our AA value, and then I'm just going to zero out the upper 4 bits, and I'm going to store that, and I'm going to load the value in the attribute memory, and we're going to end that, and we're going to do the OR A, and we're going to store that, and then we're going to transfer X to A. And then we're going to subtract 8 to get 30. We're going to transfer that back into X so we can get the value. We're going to load temp2 and shift it to the left to get A0. I'm going to store that back. We're going to load the next attribute value, and we're going to clear out its lower 4 bits. And we are going to, or upper 4 bits, right? Yeah, upper 4 bits. And then we're going to or the attribute value onto that, and we're going to store that, and then we're going to increment the attribute index, and let's see what that looks like for at least one. So that is looking relatively decent. Now where it gets messed up is when we are not doing, so that actually looks good for the first screen's worth, right? Like those colors are right. There's a little bit of a lag, it looks like, where it's, you know, you can see the colors getting updated, but that's, I don't know that we can fix that. That's kind of just the sort of the name of the game when it comes to the way the attributes work. I think, let me see here. Unless we're just lagging behind. I mean, it looks, maybe we're updating the wrong, locations in memory, and that's why it looks like it's lagging behind. We can get to that in a second. Let's implement the non-split mode, because we're not doing that at all. And then we can deal with this. So the good news about that, it's going to be a lot simpler. So we're going to load a romem y, which has the value completely set up the way that we want. And then let's see. So all we need to do is just store that into the attribute buffer. So we're going to load x attribute index. We're going to store a into attribute buffer x. And then we're going to increment attribute index. And I want to say that's it. It's much, much easier. Right? Because we're loading the value, which was already shifted in properly. We want to set all of those attributes. We want to set up X so we can store it in the buffer properly. We're going to increment the attribute index. And then by the time we're done, Yeah. So that's that. And then, oh, the only thing we need to do at the end is, so just like in here where we are, if we're in split mode, we need to subtract 16. So in the case of, yeah, so that's fine. So in the case of both situations, we need to subtract 16 to go to the next row in the buffer memory, or the previous row, really. But if we are loading with, when we're not splitting, then we're taking the attribute index, we're adding 8. Let's see, we're transferring A to X. 2, 3, we're transferring X to A. We're clearing the carry, we're adding C0, and then we are storing A into 2006, and then we're loading with 8. I mean, that seems right. That seems right. So let's see how this looks. So there's still obviously some sort of problem. Let me think about this. Oh, okay. So there's still a problem where when we subtract 16, after we're done, let's see. So we're going to subtract 16, and then what we need to do is we need to say branch carry clear, branch carry set to did attribute did not wrap, attribute did not wrap, and then here we're going to load A. What was that value that I came up with before? Was it 38? Yeah, 38. So basically this is if we subtract to go to the next row, but the next row is, you know, we're at 0, so we wrapped around. We don't want to go to the, we don't want to go past 64 bytes, which is the size of the attribute table. I have a feeling that's why we're seeing that weird corruption in the name table. Yeah. So interesting. So it's partially right. It's not exactly right. We're still seeing some, we're still seeing some weird problems. Let's see, where are we at? We're at about 2 hours here almost. Let me see if there's anything obvious in the next couple of minutes here. Let me see some things. So C0, let's see, if we have 38 plus C0, that's F8, so 2C F8. That should still be within, well, let's see. did I say? 38 is F8. And it's 23 F8. So 2400 minus 23 F8 gives me 8. So that, yeah, that is right. That would be the last row. So that's good. We've obviously traversed into the unknown here. I still feel like we're updating the attribute memory slightly out of sync with the row updates. Is that because, let's see. Should I have used a different... I mean, 38 plus is 40. That seems like that would be wrong. But that also, up until a moment ago, seemed like it was updating a little bit more correctly. No, those attributes are wrong there. So, oh, wait a minute. I'm just a bonehead. Modifying the wrong stupid thing. It's actually worse. It still appears to be having some strange issues with the if we watch the name table. Let's reload this. You'll see that we'll start getting some potentially random data getting in there. So that just means we're updating the name table. I wonder if my address, my base address for that is wrong. Because it's 32 by 30, so that's 960. Except I should do it in decimal, so that's 3C0. So I go into the PPU memory. If I go to 23 C0, that would be the first attribute, and what we should see in the name table is that if I modify that, yeah, that does change. So that is the first meta tile. And now what we're saying is we're doing 23C0 plus 38 hex 23F8 23F 1 0 1 2 3 4 5 6 7 8. So that's definitely that there. And then that there. So if that were, that's palette 2, is that right? No, it's palette 3. So palette 3 is 1 1, so it'd be 1 1 1 1, which is F it palette 3? 0, 1, 2. No, it's palette 2, dummy. So it's 1, 0, 1, 0, which is A. Okay, so it was AA, AA. So that's what it should have updated it to. It looks like it did. Oh, okay. Is it because it's not... no. I was going to say, is it because it's not updating the palette memory until after the first row is drawn? I mean, that... Let me start this here. Let me rebuild this with the right code here. And let's go back to all of this stuff. So 23C0 is here. 23F0 and F8 are there. So let's see. I mean, that all looks okay. It's just some of this stuff here is not right. And I can't tell why that is. Why would it not be loading uniformly across the screen? Interesting. Well, I'm not sure we're going to solve that mystery tonight. Could also, well, no, I was going to say it could also be the way the emulator is displaying it, but it doesn't seem that way. And then it's not 100% accurate for the ones where the meta tiles line up. Like, those should be the simplest cases, 2, 3, C0, and it should be pretty straightforward for it to do the update, but we can see by the split colors here that it did not do that 100% accurately. So something is wrong. It could be the attribute buffer initially doesn't match the screen. I'm not sure. Well, you know, we've made a decent amount of progress here. I wish I could have gotten it 100% working, but it's at least updating the attributes reasonably well. Or at somewhat. I mean, let's see if it helps if we get rid of the cropping on the top here. If it makes it more obvious what it's doing. Like, I don't know why that wasn't already set from this. Unless this is setting... Unless it's setting... Oh, yeah, maybe. Maybe that needs to be... Because we're scrolling up, maybe it needs to be off by... Oops. Off by 1 to accommodate for that. That's looking a little bit more like what I expected. Store A, adder index, load A 38. did it not? Subtract 16. Attribute did not wrap. Store. What about here? There's supposed to be a part where it's checking for that. And yeah. Oh, it's not storing it. Oh, well, yeah, I guess it wouldn't need to store it here because it's just, okay. So let's see if that. Well, it's better. That's definitely way more consistent. We're still seeing, it looks like a consistent bug with this particular one. If we go back to this and we crop it for a second. Overall, let me see. Or is it right? No, actually, no, that's not right, because that should be that dark blue over here. So it's actually not better. Let's see. Did I just go in the wrong direction? I'm kind of guessing now. I'm tired. I'm just trying to see if there's some sort of off by one error messing around with it. Yeah, that obviously made it worse. All right. Well, like I said, it's we've been going on this for a while. There's obviously some sort of issue with the way it's doing this. It's not too bad. I mean, we're getting most of it working. It's mostly working. Obviously not something that we would consider shippable, but the colors are at least partially correct. We can see that there's some sort of problem that's manifesting itself where it's only half updating some of these. Maybe they're off by one and the color is here and the skip mode is incorrect in the way it's offsetting things. Oh, you know what it is? Also, we're never actually turning off skip mode. That would also impact. That would also do it. Let's see here. Store a adder index. Let's see. If the attribute wraps, then we actually need to load a 01 store a adder mode. Sorry, 0. No. Whatever it is, we want to flip it. Load a adder mode eor1 store. So whatever it was, we're going to flip back and forth, right? That's what we need to be able to do. We weren't doing that before. What? Subtract 16. If it didn't wrap, we go here. If it did wrap, then we're gonna, oh, that doesn't work. Weird. Load a attribute mode. Exclusive OR. So if it was 1, it becomes 0. Are we using that here somewhere? That it's a problem? No. So let's see. Skip modify attribute index, load attribute index, subtract 16. Let's see. So if we were doing the well, actually it shouldn't be 16, should it? We're okay, yeah, we're incrementing it, so I guess it would be 16. Oh, and this is wrong. Oh, that's craptastic. So it shouldn't be 38. It should be whatever the offset is. That would be true if it were 0. But, so what I really want to do is if we say, okay, so if it's 0 and we subtract 8, and then we can add 4 0. No, what is it? F0? No. 40. So if we add 40, then we get 38. If it was 1, and then we subtract 8, and we add 40. Okay, so instead of just loading that, we actually want to clear carry, add carry, 40. The reason we want to do that is because we want to push it to not only be the last row, but the last row offset by the offset that we were at. So like if we were at the third element at the topmost part of the buffer, when we wrap around, we want to be at the third element at the last row of the buffer, and I was just setting it to the same element every time. So let's see. That looked better. And then attribute index, we're subtracting 16 from that. Oh. This can't happen here. Can't happen here because we need to know what the mode was. We need to know what the mode was in order to determine how we're going to load the attribute table. So let's see. So the attribute index, we either want to subtract 16 either to get to the row that we're loading directly, or the, let me think about that. So or the row that we just modified would be +8. So this, let me just do this. So oh, this is all sorts of stupid. And I say that because if, for example, we're at the bottom or the beginning of the buffer and we subtract 16, we're gonna overflow or underflow, whatever, the byte. And then when we go to add the 8, we'll have made it 38, which will make it too big, which is no good. So let's see. So if we subtract 16, what we really want to do is, I think we want to do this. We say, okay, if we wrapped around, we want to make it be 38. That's okay. Because if it were 0, no, actually that's not right. What we want to do is we want to clear carry and add carry for 0 like we did before. Because if we're at 0, we want it to be 38. No, I'm sorry, we don't want it to be 38. We want it to be 30. And if it's at 8, we want it to be 38. So, okay. So, right, let's make sure that that works out right. So if we're at 0 and we minus 16, add 40. Yep, and then is 8 minus 16. Uh, 8 minus. I'm mixing up decimal and hex digits here. Plus 40. Yeah. Okay. So that's fine. That's going to, if we've wrapped, we're going to wrap back to the right position. And then if we're in split mode, we're loading X with that index, etc. Okay, and then we're doing this, and then branch carry set clear to wow. This is kind of dumb. I feel like there's probably a more elegant way to do this, but basically if we then add the 8 back, well, this isn't going to carry. Compare it to 64, which is 40. Oh, Lord. So if it's greater than, so let's see, load a 38, compare with 40, so then we'll run. So that was less than. Right, so carry will be set. Carry will be set if the value is greater than or not equal to, right? Just greater than? No, greater than or equal to. So branch if carry is set, carry is clear to did not rewrap. And if we got a carry as clear, then they're equal to or greater than, in which case we want to set the carry and subtract 40. So we would get 0 or some other value that's more appropriate. All right. Well, that's obtuse. And then we're going to transfer that to x, which is our lookup. And then let's do this. Clear carry, add carry. What I want to do is I want to say, okay, if we wrapped, that means we need to switch modes, right? So what I want to do is I want to load A with adder mode. I want to EOR 1, store that in temp2, and then once we're done with all of that crap, branch not equal, which this is the same for both, then we're going to load A, temp2, store A, adder mode. So basically at the end of all of this, we're going to say, all right, update the adder mode to reflect whatever actually it should be. This is still broken. All right, I'm going to stop now because this is long, and I feel like I'm just missing something because of the way that I've ended up making this convoluted. As a result of some of the things that I wasn't thinking of. And I don't want to leave it like this. This is so annoying. The carry is set, then we didn't wrap around. Flip the bit on the attribute mode. Store it in temp2, clear the carry, add the carry, so add 64 because we've wrapped. So we want to re-wrap accordingly. Oh, I wonder if we maybe don't even need to do the add. Could we just do an and? We're at 8 and we minus 16 and 64. 8 minus gives me F8 and 64 gives me 64, which isn't quite right. It's F8. Mod 64. 56. That's what I wanted it to do. Oh, it's not, because, yeah. That's why. It's do 8 minus that, and then it's F8, and if it's fourth, it's 3F. 56, and then what did I say? So F8 mod 64. Keep mixing my number systems. 40, 30. That actually worked. We could do that. Anyway, I don't want to get into that. That's so we're storing that into attribute index. So that's our next row that we need to update. Now we're going to load attribute mode. Oh. And we need to AND it against that to see if it's split or not, because it may have that extra bit set from the flag before. Still not right. Compare it with split. Load branch if not equal to load attribute address. It falls through to load split. So load X the attribute address. Let's do this like right here. Well, no. So load X the attribute address index. Then we're going to set to 3. Into the first part of the address in 2006, and then we're going to transfer X to A to get whatever the attribute index offset is. So we have that value. We're going to clear. We're going to add C0 to it. And then we're going to store that into 2006, and we're going to load Y16. Should we load 17 because it's doing the comparison off by 1? But that's how many. We have to update 16 attributes, right? Because we have to update the row, one half of the row split, and then another half of the row split. And then we're going to load the attribute values. So X should have the attribute index for the attribute buffer, and we're just storing it in there. And then we're incrementing X, decrementing Y, and comparing it to 0. And then if it's not equal, we're going back to load attributes. So we're doing our, in this case, we're doing 16 increments. X, let's see, X would be, at the most, X should be 38 plus C0. So, well, but it shouldn't do that because, let's see, we would be Oh, I wonder. Well, so we'd be adding 1 every time. 3, 4, 5, 6, 7, 8. So we'd end up with 0. And then we'd minus 8. And then we'd add 40. And we'd end up with 38. And then we're updating. That might be the problem. All right, we'll continue this next time. I think I'm incorrectly starting at the wrong position in the attributes, but we need to step through it, and it's 2 hours and 40 minutes on the stream almost now, 2 hours and 30 minutes. And I'm going to wrap this up. We've got most of this working partially correctly. I mean, this was kind of the hard part, and now we just got to kind of tweak it and make sure that we squash the bugs that are in here. I'm sure it's got something to do with the starting index and the way that we're doing the wrapping around as we hit the boundaries of the buffer, given that it's a 64 byte buffer and not, you know, the 255 or 256 values that we're normally using when we do the comparisons. So yeah, so the values are partially loading. We're getting some weird behavior. It's actually updating the name table in some cases incorrectly. We will get that solved. But in the meantime, I will post this recording like I have with all 37 other ones on YouTube. Feel free to comment on that if you have any questions. You can reach me on Twitter at Clairvis. I am also on the Nintendo Age Discord chat quite a bit, so you can reach me there, or if I'm not there, there are plenty of other extremely knowledgeable people on there and on the forums at Nintendo Age and NESDev. Did I say the NESDev Discord? I meant Nintendo Age, but anyway, just to clarify that. So yeah, hope you enjoyed the stream, found it useful, and I will see you Monday. Have a great night. Thanks for watching. Have a great weekend. See ya.